Uh, I'm head of weather resilience at Network Rail, and I work very closely with the climate change team as well, and have been doing for many, many years. The forecasting fascinates me. We've been developing tools with our forecast providers over the years. We've had many, and the tools just continuously progress for us. But and the science rapidly speeds up, and we use ensembles. We use a whole mixture of things. But at the end of the day, we make kind of quite binary decisions. And I shouldn't say this, but we either slow a service down or stop it. And understanding that those parameters are really key for us. Understanding the impact of weather on our assets and the overall operational system of systems is fascinating, and is something that I've been working with Loughborough University a hell of a lot in regards to sort of complex systems, full stop. One of the things our engineers seem to be obsessed with is their individual assets that they look after. So if they look after overhead line equipment, they would never talk to the guys in track. Track will never talk to the people that do the vegetation. The vegetation don't talk to the people that do the earthworks, and the earthworks are a completely different set of people anyway. And there is a lot of silo thinking, and of course the key thing for me is that when you go into these meetings with asset managers, they talk about their little babies that they're looking after, and not once do they ever mention the passenger or the freight user. And of course, they basically pay for their jobs and pay for our forecasting systems too. So I come at it. I've been in ops for many, many years, and I come at it very clearly from an ops background. And if the passenger isn't benefiting from anything we're doing, then you have to question why we're doing it. And there's some really fantastic systems out there, but at the end of the day, how does it impact what we do in regards to the management of the railway? And I love this one. Our chief execs were telling us that safety and performance go hand in hand. Well, not all the time they don't, because if you make a system really safe, you often slow it down. Certainly at the start, where you go through that kind of bathtub curve of realizing what you're actually implementing. And I'll show you some examples. I know I've not got that much time, and I can talk for England. And by the way, I do a lot of drawings of weather events. So if you want to buy one, I'll be hanging about after. So just to give you, I'm going to give you a very, very brief overview of some of the things that I'm sure you're familiar with the railways. This was a derailment in a tunnel at Summit Tunnel at Todmorden in West Yorkshire. That derailment wasn't that high speed, but it was in a tunnel. You can imagine being on that train, coming off in the dark, all the lights going out. That's essentially a tunnel shaft freezing up, and then eventually all the ice just dropping through. And when it comes to wind, you know, I love this. We're not actually, you can't, well, I can't say you can't blow a train over. We've seen some fantastic videos of stuff in the US where you get a tornado, which we'll do. But essentially, the problem with wind for us in the UK on our rail network is people's trampolines. Weirdly enough, lots of vegetation, and classic Network Rail, we divide vegetation up into two realms. Is it our tree or is it their tree? Because if it's their tree, it's their problem, and we don't manage it, and then it just drops across and then shuts the line. And this, for me, is an absolute killer for the network. This is just a bit of plastic that's wrapped around the overhead line equipment. This is 25,000 volts AC. When that gets wrapped around, it trips. Everything shuts down and has to be taken off. You have to shut the whole thing down to take it off. Bits of plastic, anything really, balloons. When I can say this now, when before the Queen passed away, there was a big plan around Operation London Bridge, as I'm sure you're aware, where she was actually her body was going to come down the East Coast Main Line. For about the last 5 or 6 years, I've been involved in the planning of that. And one thing I keep saying is, can we please switch the overhead line equipment off? Because it was diesel haul train anyway. Because if you've got people at level crossings with balloons and banners and things at bridges, 25,000 volts and all that, and in the end, they pulled the whole plan anyway, as you know. So we're really vulnerable to not necessarily the weather elements, but the kind of secondary and other impacts of weather. Temperatures. Now, there's a lot of talk about buckled rail. You know, we do a lot of work with the Met Office and other forecasters, but this isn't such a bad thing. But we don't get that many. We did in the old days when it was all jointed track and it went clackety clack, clackety clack. This is continuously welded rail. It's stressed out to very, very high pre-stressed temperatures. We tend to get these issues because the maintenance haven't had time to pre-stress it when they put it back. That's generally where you get a buckled rail. It's quite unusual. Obviously, it's an issue because you don't want to be going over that line speed because you will derail, but it's very rare. What isn't rare is this. So, well, it's rare, thankfully, in terms of the weather event, mainly because in the southeast we have this rail up here, the one that's furthest out. It's a conductor rail, and the train draws current 650 to 750 DC current, and that draws from a shoe on the side of the train into the traction motor. Years ago, our old trains would smash all the snow and ice off. That wouldn't be a problem. These days, lots of the trains that we've got now, the new rolling stock, have got very, very small, what we call shoes to pick up. They're very fragile. And because they're all got full of computer board systems on board to protect the train, if it's not drawing the correct current, it shuts itself off so it doesn't destroy itself or burn itself out. So that's become more, we've become more and more vulnerable to conductor rail icing. And then there's general things like snow in couplings. So this is an automatic coupler. So this lifts up and the train's joined together like this. Obviously, if it's frozen, those bits don't work. They're mechanical parts. And the same as brake blocks. Normally, don't worry, it's not normally on your passenger trains. It's normally freight trains. Wagons get stuck and then they drag their brakes. They actually fail safe. But then you've got a dragging brake for miles, which creates a wheel flat, creates heat, and sometimes burns the axle itself. One of the biggest issues we've got really with heat is if the heating in the driver cab isn't working, there's no way that train's going out. And that's just part of industrial action, which I'm not going to get into today, but there's no way a driver will take their train out if their cab heater doesn't work. And there's lots of weird things like this that we've done a lot of work with in regards to heat, temperatures and passengers, especially passengers stuck on trains that have been stranded for some time. Autumn, the leaf problem. I'm not going to go into huge aspects of the leaf problem, but it does cause some severe damage to wheels, and then they have to be taken out and turned on the lathe. We do have sanding systems to prevent that slipping. But the key thing around leaves is not necessarily slipping. It's they insulate between the wheel and the rail, which of course activates the signalling system. It's very old-fashioned. The track circuit will be activated. So once a train passes a signal, the wheel rail detection makes sure the signal behind it goes to red to protect that train. Leaf litter, once it's rubbed in, goes like Teflon material, like this, and that insulates the rail. So essentially, you could end up with a train not protected by the signal, which is just it's not an option. And the potential, obviously, for that is a collision. This was taken last year. I was on site following the collision at Fisherton Tunnel in Salisbury, where again a train went into the back of another one. The driver came around the curve. There was a junction into the tunnel. He saw the red signal, made a brake application. The speeder goes to 0, which is always scary as hell because you're actually accelerating at that point, and slid into the back of another train going into the tunnel. Thankfully, nobody was killed. The driver was injured, but these are the sort of things that are really key to us. So I'm here to talk more about forecasting and what we do with our forecast. We've currently got a contract with FRMetS, who provide the forecast for us, but we do a lot of work with Met Office and other suppliers, but mainly Met Office. This is an example of a real fundamental basic 2 to 5 day forecast that every control in the country receives 0300 in the morning and gives an indication through a red, amber or green status aligned to our standards. So if you have an adverse, you're looking and go, well, don't really have to do much because it's just a warning. If that goes to red and extreme, then it sets off a process called the Emergency Weather Action Teleconference process. And we do that two to 5 days in advance. so that we get all the delivery units, the maintenance teams, and all the ops people and all the train operators together to discuss what that risk looks like. Now, thank you, because we're looking at the risk for snow and ice at the moment, certainly for the next few days. We've alerted, I think we alerted a -8 on the Highland forecast today, which does actually breach our threshold, which is at -8. It's extreme. Now, the interesting thing is nobody knows where any of these thresholds have come from. A lot of them are grandfather, sort of, somebody said it a long time ago. Why do we reduce speeds to 50 miles an hour? Nobody knows. Every country in the world does it. We've done a gap analysis with rail safety standard boards. Nobody knows why. We spent thousands of pounds working it out, and they told us we don't know. So again, at 40 miles an hour, we do know that if a train derails, it's likely to stay up. Why they've picked 50, we don't know. But it's not just the 2 to 5 day forecast. We do use ensemble forecasting a lot. We work on lots of things around teleconnections, certainly for winter, and its impact on us. And we do big seasonal preparedness. This is just a really bad slide, actually, but it's just an example of some train operators here that they are given a series of questions about how prepared are they in very specific things. And we do 3 stage gates over the period of about 3 months, about 2 months prior to the season itself, so that they're preparing their fleet and we're preparing our maintenance and ops. And then we create these tables, and often you say, well, look at that little red there, what does that mean? And the narrative behind it will mean probably that there is a set of points somewhere in the middle of Norfolk that haven't been painted white for a hot day. Which is okay, that's good. It's if one of those reds turns out to be that, there's industrial action at the same time as autumn, which has been recent, then you're in real trouble because you might not be able to run your mitigation. And just to give you a kind of very brief overview of some of the armoury we have in our toolbox, we have independent snowplows. These are built on steam engine tenders. That's how technologically driven we are. These are built hacks. These are for about these are 6 foot snow. That's for doing anything 8 foot snow and beyond. And we do get 8 foot snow drift simply because of some of the cuttings that we've got, certainly around some of the freight depots and entrances, mainly to some of the big power stations where you get single lines really heavily embanked. We've also got the snow and ice train. This does blow hot air onto switches and crossings to clear them. And this is a snow blower. It's the same technology they use in Sweden. I think we've got 2 of them up in Scotland that we do use every now and then. And then we've got our favourite multi-purpose vehicle. These poor things run around the network. The modules on them in autumn, they water jet the running van, the running rail at 1,500 bar. If it slows down to about 3 miles an hour, it starts cutting into the railhead, so it switches off at about 5. We normally treat around 60 miles an hour, including all the railhead, every night around all the network, every night through autumn and some of the day. This time of year, they switch over these modules to do the anti-icer. So the conductor rails here, which I showed you in the last picture, when there's a particular threat of them being iced up. So I've briefly explained. Sorry, this is really quick to know, but I briefly explained the 2 to 5 day forecast that we use. That's obviously based on big weather regimes where we've got a variation or difference between weather regimes that are being shown over our geographical forecast areas. Our geographical forecast areas were created around our delivery units because we were, again, very historic, very much focused in that culture of response and recover, not about predict and prevent. We had a tragic train accident in 2020 up at Carmont near Stonehaven, where HST doing 74 miles an hour hit a landslip, come off the rails, went up the side of a bridge parapet and dropped down, killing 3 people on board. There was actually only 12 people on board. That train would have normally been, outside of COVID, about 200 and standing. It killed the driver, the guard, and a passenger. And I went to site, and I've never seen anything like it. And it was just incredible how people could have even got out of that train. The forecast for that day, ironically, we held what we call an EWAC. We did a national one because of the heat. And what we realised is that the heat coming up over the UK at the time actually created a lot of convective showers out sort of north of England into Scotland, and certainly over to the peninsula of Aberdeen that night. The risk we saw was heat. We didn't see this coming at all because we'd never forecast convective rainfall. We never have. We only look at 2 to 5 day systems. So we had to develop a tool pretty quick. And we developed a tool called the Convective Alert Tool, the CAT. And it's based on much more granular data points now that we're forecasting on. So essentially, each one of these, what we call Smarties here, is between an operational route section, basically between a station to station. Because what we realized is that convective events in regards to these type of events that happened at Stonehaven, we kind of got an idea around 3 hours in advance of roughly where these things might pop up. And of course, it's much more granular than the systems that we've been forecasting for years in a 2 to 5 day forecast. Breaking that down into a railway is a nightmare because we've always historically forecasted for a geographical area. So, for instance, the Perthshire area for us covers from Carl of Lacalche, from Thurso, Wick, right through to Aberdeen. That's one geographical forecast. And of course, our rail network is like a thin line going through that mass. So it's not rail specific. It never has been. We started to try and tailor the forecast to something more rail specific. And we learned a hell of a lot of lessons because what we realized is that now we're alerting all the time, slowing trains down for absolutely no reason half the time and decimating performance. So it's been an absolute nightmare, and there's huge reviews about what we're going to do with this. Alternatively, not just for the rainfall, but Paul Davies at the Met Office and I were working on the Weather Advisory Task Force with Dame Julius Lingo on the back of what happened at Stonehaven, and we decided to develop the operational route sections. And so I should have explained. The operational route section from stations to station simply so we can alert the driver through a radio call that they don't have to acknowledge, because again, with the unions, they're not allowed to acknowledge anything like that. They're allowed to hear it, and then they should slow down into the next section if we're hitting an extreme. So Paul and I looked at how we could use the operational route sections to do other weather parameters over the top. And this was just the trial period. This is the Tweed Bank line. This was closed by good old Beeching, I think, many years ago. Reopened probably, maybe 6 or 7 years ago. Brilliant bit of new line. As you can see there, Paul's forecast picked up some of the ambers there. And we said, right, what are we going to do about this? And then literally, I got a phone call to say, oh, the Tweed Bank line's closed. And so I phoned Paul and said, look, your forecast has worked, but it's not extreme. We'd gone to amber, and we'd had a small amount of snow that had gone over the top of one of our, you're not going to believe the irony of this, a snow heating point work. When you get too much snow on the point heater, it insulates, it gets warm, and it doesn't trigger it. So the point heater wasn't actually working. If it had worked, this line would have carried on going. So it's trying to understand the complexities around our maintenance cycles and what we actually do with the forecast. That's the key to this. And then just to end, what we're also doing, and it goes to the point that we don't really understand the impact of weather on our services. If you go to any of our control centres, there's lots of people sitting there with information coming at them all the time. Obviously, not just weather, people deciding to, get rid of themselves or animal incursions, you name it, it happens. And all these things are going on at the same time. If we get a 2 to 5 day forecast that's triggered, straight away, any delay that comes in, they'll say, well, as the driver reported, it's a lightning strike. As a driver reported that there's flooding in the area. And then a lot of this goes to an external attribution code. So they put loads of this stuff in for the weather. And it just builds up, and we don't really understand the impact. And the only reason I know that is because I did a lot of work when I was in Anglia route around lightning, and we had some really good spherics data and I took it and I cross-referenced it with every lightning strike that had been reported through our control. And I used the Meteorage site back then, a long time ago. And I think there was about 60% error in our reporting. That was equivalent to about 3.5 million quid. And it was wrong. It was just totally wrong, but it was attributed over there. And we make business cases with this stuff. So, you know, so the key to this is that I wrote a paper to the great and the good saying, you know, if we keep believing that this data is correct, we are never going to get out of this. So we need to look at what we can do, or I came up with a proposal of what we should do to look at the individual impact of weather events, not just individual weather events, but the combined events or combined impact on individual head codes, individual trains. So if you're on a train and you know it pulls to a signal, you know you don't really care what's caused it. You just know you're going to be late. But again, our asset engineers are obsessed with, was it this or was it that? Can we blame that person? Can we take money from them? Do we have to pay them? And it's that kind of thinking. And what we're trying to do is we've developed this paper that proposed something like what we're building now, what we call a seasonally agnostic railway. I hate the term agnostic. It was our industry decided that's what it should be called. And the reason for that is that we are not going to spend billions of pounds on every embankment to make it safe. It's just impossible. Most of the stuff we don't know. We have high-risk sites. We have over 130,000 of them. But we often get failures in sites we have no idea about. They're not on our risk register. And all we do is ever build up our risk register, get bigger and bigger and bigger. And we never really understand, or no one's actually got the confidence to take away or take that off a risk register, even if they've done some remedial work. It's really, if you do that, it's a very brave person to take that way. So we build more and more and more and more. What we see is perceived risk, but we don't really know if it's risk or not. So this model, it uses the operational route sections. It uses so much more granular focused forecasting on the rail network that's specific to the line of route. We've used the Paul Davis stuff that we've been working with Paul in regards to the operational route sections, but forecasting other parameters other than precipitation. So we've included heat and wind as a starter with some of that. And then we've overlaid things like asset information for individual operational route sections. So between any one station, there's probably over 30 to 40,000 assets in that, just from one station to the next. We need that information. We don't need it hugely granular, but we need to understand that the combined effect of all those things, if something goes wrong, is the key functionality between each signal. And that's what we started to do in a pilot, weirdly enough, on Western between Reading and Bedwin. And we then apply the asset standards over the top of that to see that we can do what mitigations we can actually impose on that. And then we run the real timetable, because you know we do a lot of modeling, we do a lot of digital twin stuff, but actually if you don't know the impact on real timetables, I can't come up with a real business case to say that's actually delayed. And if you delay a train between Reading and Bedwin for 3 minutes, you're probably looking at about 1,000 to 2,000 minutes delay, and probably delaying everything from Penzance to Aberdeen down to Brighton, because by the time you've gone into Reading late, as you know, will affect everything, including all the freight flows across the network. And Reading's got a lot of freight flows. So it's starting to understand the overall impact on that. And of course, the most important bit is that if we know that a certain systemic impact on the network at a certain point will cause 3 minutes delay, and that will aggregate across all those operational route sections to 10 minutes delay, but the driver's only got 5 minutes to turn around that train at Newbury Racecourse and come back, then you know by the time that's been done 3 or 4 times a day, and that could be done 16 times a day, we've lost your service instantly. Not only that, it's then impacted all the others. So what we've done is we've cleverly building this so that we can quantify the impact, go back to the Department for Transport. And my feeling is the most resilient railway, the most agnostic railway, is having a timetable that when you get a 2 to 5 day forecast with good confidence, like we did this summer with the heat, you press a button and it uploads a timetable and it goes into all the downloaded systems where people are buying tickets. So it tells them instantly that that train is either running, that will be late, and you've got an amended plan. Because at the moment, we don't do that. We wait till last minute. and I've got loads of information from our last summer review. Everybody waits. Everybody waits. Is it really going to get to 40? Is it really? And then they're in the control. So 2 days out, 2 weeks out, we've had this information with really strong signals. We're saying, please do something about it. But then they say, well, we'll implement the plan. What plan? It's that everyone sits around a control in the middle of all this stuff coming at them with extra stress, no more resource, building timetables, knocking trains out. That's why when you stand at Reading or anywhere on the passenger information screen, it goes blank because they don't know. They're still working out. Yeah, but we could be doing all this in advance, but we can only do it in advance because if we can quantify the impact, it's certainly about the money, quantify that that's the revenue loss you're going to get, and the Department for Transport or somebody is going to have to pick that up. And that's where we are. But that for me is an agnostic railway and resilience. It's not going to look like the Shinkansen railway because we are not going to have an earthquake-proof railway. Thank you. But I don't overrun.
No, you haven't. That's absolutely amazing. You're developing this quite exciting system. You can almost sort of plug it straight into our forecast, and your job's done almost.
Well, interest as well. You could plug it into some of the UK CP18 projections and things for those areas, and you still get an output. Yeah.
Do we have any questions in the audience?
Yeah, really interesting. You mentioned at one point that you use ensemble forecasts as well, and what you've got here, albeit what you said at the end about the planning isn't as good as it might be about how you're going to use it, but that's essentially a risk-based type of system. So at the top of it there, you've got given the weather forecast, but have you thought about, or could you build into that, given that weather forecast being a probabilistic forecast, the probability of certain things happening is over a certain threshold rather than just it's going to be 40 or it's not going to be 40. Is that something that's built into what you're thinking?
It is, and this is awful, but only a few years ago we were using lots of 15-day ensemble information to routes, and they kept telling us, what does this mean? How can we use it? They want a very basic, is it going to happen or isn't it? And so what we've done, it's a really good question actually, because so what we've done with the probabilistic stuff that we've got now is actually tailor it to our long range forecasts, because we still take the certainly 3-month forecast that we give certainly around this time of year, and things like sea surf temperatures and all those sort of teleconnection stuff, polar vortex things, we've always built in. And what happens is that the controls, they'll say, well, so what does that mean? So we are developing something that gives a clear indication, mainly about resource more than anything else. Because if you see, as we did certainly from, I think it was 2010, December 2010, when we were really hit in the south with snow for quite a long period of time and ice. Certainly in the forecasting at the time, you know, that we had some really good indications of some of that was signalling, you know, that might happen. And I think it's about how we communicate the seasonal preparation bit rather than the controls, because the controls will always want a binary decision. But a lot of people doing the planning and the timetabling, I think they're the people that need these seasonal forecasts. So I'll give you an example. 2018, we were hit really bad with earthwork desiccation in the southeast with the clay soils. It really messed up our track geometry. And it wasn't until about September, October, we really started to feel the pain. And it just felt so dry and everything and all that. And what happened was the knock on to maintenance, that the planned maintenance then couldn't take place and had to take place much further into. And then that affected the engineering works that we got planned for Christmas and New Year, which is worth, again, billions. And you see, so for me, it's using it in a different way rather than control. But to be honest, we're still trying to work it out. But the probabilistic thing should be used for planning, definitely. The ensembles we need for planning.
I think the point I'd make to that is that uncertainty and probabilistic forecasting isn't only an issue for the long range forecast, though. It's also I mean, you were talking about 3-hour forecasts of convective stuff for landslides, and that could be probabilistic as well.
Yep.
So it's something that's worth thinking about in how you would respond to them in your planning at every time frame, not just in the long range planning. It's really worth thinking about.
Yeah, no, it's a good point. Certainly with the capital.
This is hugely impressive. I wish you well. But what really interests me in it, because I'm interested in this sort of thing across the spectrum of users of weather forecasts, is whether it can be used to identify the sensitivity of your knowledge, the sensitivity of the outcome to your knowledge of these individual boxes. So can you look at it and say, actually, the primary sensitivity is to my knowledge of the asset configuration, not to the weather at all,
yeah,
or whatever. So, I mean, are you planning to use it that way?
I hope so. Certainly this, because what this does is that it's not about every component of every asset in every ORS, because that would go into but what it starts to do is it shows the vulnerability of the asset type. Yeah. So you might have a specification for overhead line equipment certainly in the Great Western on your fantastically new overhead line system. But actually, if you go south of Reading, as far as Heathrow Junction, it's a completely different system, which was built a lot earlier, and the vulnerabilities are much weaker or stronger, should I say. So where those two things connect, they're the important bit. Now that's what this will start to pick up, and it's those key functionalities of assets. That's what it will pick up, hopefully. But again, my concern is that it's guilty knowledge. The more and more granular information we've got, is anybody going to keep at line speed when they know that they've got those sort of vulnerabilities?
I had a question about climate change. You mentioned buckling rails and so on. Yeah, I think you very briefly mentioned a CP18. So does your planning extend to looking at how, let's say, the probability of 40-degree days is increasing over the century in terms of making, let's say, longer-term infrastructure investments in the type of track that would buckle less, or maybe other things related to climate change, where again, UK CP18 will give you a kind of probabilistic assessment of the likelihood, the increasing likelihood of situations that have an effect on the railway system.
Yeah, so I'm going to do a very slopey shoulder answer to that. So we've got a climate change team in Network Rail that we work with, and they develop policy. And they also determine the asset specification for long term. That is not really part of my world, but we talk with them all the time. We're dealing very much with the day-to-day and then trying to deal with one season to the next, but obviously informing them of what we know so they can build it in. But yeah, so the climate change team in Network Rail, which is 2 people, by the way, for about 60,000 people, are looking all the time at policies and specification. But to be totally honest, because we're at the cold front, we see this every day. On the East Coast Main Line, for example, the overhead line equipment, the threshold for air temperature is 38 degrees. Beyond that, it's not designed to work. What we know is that there's components within that will never work at about 28, 29, because they've already started to perish in certain areas. And we've only found, and then there's these wholesale campaigns of redoing things, which I'll be retired before they get to York. So, realistically, I think, it's great having these policies, and there's stuff, I shouldn't say this, there's stuff in the public domain, not just by Network Rail, but by the wider rail industry that says we will be doing this by 2050. But actually, that's on an assumption based on what we're performing now in our assets. And I can tell you that there are elements of our assets, well, tunnels, that are nearly a couple of 100 years old, that we're not just going to be able to dig up and get rid of. So, and it's the systems thinking. But yeah, to answer your question, I'm not involved in asset specification, and I'm glad I'm not.
If this gets all implemented, what's the business case? How much money is going to be saved? Have you worked that out?
where we have, but it all depends on risk appetite. So, you know, following the, you know, if you kill 3 people on a high-speed train in Scotland, are you suddenly going to decide that it's a great idea to carry on at line speed? Even though that when that train came off, and this is the irony of Stonehaven, is that the amount of debris on the track was very little. You could argue it wasn't even anything to do, well, not a lot to do with the rainfall, because the rainfall at the time wasn't huge. It didn't even hit our extreme. The design of the drain itself, the drain didn't have to be in the first place, etc. Our landowners who was actually on there, etc., etc. You're building these things, and they're really complex. You know, so yeah, I'm hoping that, you know, the thing is with industrial action at the moment, it's got such a focus. It means that we can get on with this. and you know, unfortunately, that's the case. That, you know, just wait till something else happens, and then all the focus will be on that. And, yeah.
Well, thank